Good morning, boys and girls. So today I wanted to talk to you about humidity. It's in your notes, but some of the terms that were included in your notes, I feel like it would be helpful if there was a video for you to watch with it. So we talked about this idea that humidity is how much water vapor is in the air. And if you remember from other science classes, water vapor is the gas form of water. Okay, so a lot of what happens in weather has to do with the water vapor in the air and how it's changing and how it goes through phases. So the first thing that we need to talk about is if we're going to make a graph here, right? And we're going to just, let me get rid of this. We're going to just talk about how on our graph, we're going to have two things. We're going to have temperature on our x-axis. And on our y-axis, we're going to have amount of, I'm going to abbreviate, but water vapor, okay? And one of the first facts that we said was as temperature increases, the amount of water vapor increases. This is a very important direct relationship in earth science. Okay, so that basically means that at a given temperature, the water can hold a certain amount. So let's just say that let's just say that this is 50 degrees, right? At 50 degrees, my air can hold this much water, right? Where the orange dot is. Let's just say that it was holding that much water, right? At the green dot. If it's at the orange dot, we can say that it is saturated, meaning at 50 degrees, it's at the line, so it can't hold any more water vapor, right? It's holding as much as it can. The green dot, though, it could hold more. We could add more, right? So that green dot represents, if we look at the green dot as a percentage, we would say that that is holding 50%, right? That 50% is what we call our relative humidity. Okay, it's how much water the air is holding as a percentage compared to what it could hold. Okay, that's our relative humidity. Now I'm going to just erase all this for a second, part of it. Okay, so let's just go to a different temperature now. Let's just say that now I'm going to extend my line. Let's say we're at this point here. Let's say that this is 70 degrees, right? And the air is holding this much water vapor. Well, what if we want to know what temperature we would have to cool the air down to for that amount, this amount right here, to be saturated, right? We know right now it's not saturated because it's not up at the top of the line. But what we can say is if we cool the air down, use this color, eventually we're going to hit the line, okay? So the temperature that we hit the line at, let's just say that this is 30 degrees, okay? That is our dew point temperature, okay? Our dew point temperature is the temperature that we have to cool the air down to for it to get to saturation. The reason you always see dew in the morning is because what happens is the air had water vapor in it and the air cooled down so much that all of a sudden this dew had to come out of the air because the air was cooled down, like we see here. Imagine the air was 70 degrees during the day. In the early morning hours, it cooled down to 30 degrees, and that's why the dew came out. Because once it gets to the saturation point, the water vapor actually condenses, which we'll talk more about in a few, but that's the basic idea of it. Okay, so the other thing that I wanted to go over with you today was these pages on the reference table. What they will do, now these are both two different tables. They're on page 12 of your reference table, and the Regents will often ask you questions about these, but basically it's real simple. You're going to be given a dry bulb temperature, right, which is your air temperature, okay? And you're going to be given either a wet bulb temperature or a difference between your dry bulb and a wet bulb. Notice this is the difference, these numbers up here. And you just match them. So let's just say that our dry bulb was 4 degrees. Oops, sorry about that. And the wet bulb temperature was 2 degrees, right? Well, 4 minus 2 equals 2. So I go to 4 on my dew point table. I go to a difference of 2, and I see where they meet up. That would mean that my dew point was -1 degrees. So really, you just have to look carefully and see what they're asking you. Are they giving you the dry bulb and the wet bulb? Are they giving you the dry bulb and the difference between the wet bulb and the dry bulb? In that case, you don't have to do subtraction like I did on the left there. Or maybe they're giving you something backwards. Maybe they're giving you something like this, where they're saying, okay, my dry bulb temperature is 10 degrees C, and my dew point is 8. What is my wet bulb temperature? Well, look, 10 is here, my dew point is 8. The difference between them is 1, so 10 degrees minus 1 degree, equals 9 degrees. So there's various things that they can ask you about this, but that's the gist of it. The relative humidity table is the exact same process. The only difference is now it's humidity as our answer in here, and notice humidity is a percent, while dew point is degrees Celsius. All right, that's the basics of how to understand humidity in earth science. I hope that this video has proven useful to you.